To set the scene, what we're going to look at first is a global L3 VPN scenario. The demo scenario consists of that we have 4 different sites. We have a engineering office here in the US, we have a headquarters in Europe, and one in Asia, in Tokyo. And then we have 2 sales offices in Sao Paulo, Brazil, and Mumbai, India. And in this scenario, we have decided that we're going to deploy test agents at 3 of our locations, so in the US, London, and Tokyo, and then a few in the public clouds to measure availability of those. And for the sales offices, we have decided that maybe we are able to deploy test agent, or we're just happy with having a basic monitoring for those locations. So a typical monitoring setup would consist of that between all test agents, we are in a full mesh sending active test traffic 24/7. So this means that we are, for example, doing voice over IP calls, measuring MOS scores, and checking that everything is working as it should. Or we could be sending other kinds of application level protocols, HTTP, DNS, to check how the QS is between different locations. For the other locations where we don't have test agents, we use reflection technology and simply enable TVAMP, for example, or IPSLA, and we send a packet that is highly accurately timestamped, and the responder timestamps it on receiving and sends a response packet that's also timestamped, so we get one-way delays in both directions. And that's what's called a reflection measurement. It's more basic, and it's one packet out, one packet coming in pretty much, while the active test traffic between test agents is much more sophisticated and stateful. So this is a typical layer 3 deployment. So I'm going to switch to the system to show you how this is represented in our dashboards. Okay, so this is the GUI that we provide. And what we're seeing on the screen here is a number of monitors ongoing. So as Matt said, we have monitors, which is 24/7, ongoing continuous assurance, and we have tests, which is one-time tasks, which I will explain later. So monitoring is something that goes on continuously. And I'm going to drill into the group called Global L3 VPN, which is my monitoring group that monitors this network. So as I said, I have 3 test agents in the core part and 2 remote offices. We are looking at the past 15 minutes of time here. So every 10 seconds, we update this with a status of if we are detecting any issues with those kind of test streams. So this monitoring group going between London, Tokyo, and North Virginia is all green. That means that all KPIs that we are picking up is meeting the thresholds. There is no packet loss, there is no significant jitter, and so on. But let me switch to another time frame. So instead of viewing 15 minutes, we can view the last 1 hour, 6 hours, last year, or just the last week. So here we see that we start to detect some red lines. So at these times, there has been some issue, either jitter, high latency, or packet loss. So maybe I'm curious about what happens on the link between the London and Tokyo office. So then I can click on it, and I get a drill down into the KPIs for this time period. Now this graph is showing me the average delay, which looks good. We don't see any large deviations there. But let's take a look at maybe packet loss instead. So this is a packet loss graph. So occasionally, we have issues that packet loss goes from being nothing to being quite significant. We could also look at jitter to see if it seems to correlate with jitter, and no, it doesn't seem to correlate because jitter happens outside of the packet loss because it's probably caused of different root causes. So the system keeps data, of course, for a quite long time. And besides accessing it as a graph, you can, of course, also access the raw data. So you can get all the measurements that has been done. And this is, of course, also accessible from the APIs. So this is for manually going in and extracting something. But of course, you would use the REST API to read out data. Okay, so this was our core measurement between the sites. Then we are doing the reflection measurements to the remote sites. And these are more simple. So here we're just having one sender and a couple of different receivers, just with having different responder IPs. So we are seeing, again, packet loss per direction, latency per direction, jitter or delay variation per direction, and so on. So quite raw metrics, but still very valuable to keep track of network availability. The system is also able to do path trace, so basically doing a trace route, but also keeping track on hop-by-hop performance. And that's what I'm displaying here. So from London to this location, it's one hop because we are in a VPN. So we don't see what's in between, but if there would be a trace route, like we have here, then we also do hop-by-hop measurements to find out or give an indication of where it could be, because ICMP ping is, of course, a best effort service from routers and switches. So if you have jitter or high response times, it doesn't tell you anything else than that there could be a problem that could be a CPU load or network, but you don't know for sure. While TVAMP or the test traffic between test agents is running with high priority in the right QS classes and all, having a certain expected behavior.
Would you be able to alert on certain errors?
Yes, absolutely.
On all those errors?
I will come back to how to configure that in a few minutes. But yeah, that's quite important, because just detecting the problem is the first step, and then doing something about it is the second step. And we provide a few ways to do alarming when we have a problem detected.
How granular can you get when you're talking about packet loss between two sites? Can you get down to were any clients impacted?
Right. So the resolution we have in the data store is either 10-second or 1-second resolution. So, but also during a 1-second period, we can tell you exactly how many packets were lost. So if we're sending 1,000 packets per second and we lost 2 of them, we know that the outage was 2 milliseconds. So it's basically millisecond accuracy on detecting outages.
But I'm curious, can you tie it back to an actual end user or to some kind of performance metric other than we lost some packets?
So we don't have any database of where subscribers are or so, but you tie the test agents to that this test agent represents this part of the network. So if you place it at the customer site, yeah, then it's a one-to-one map pretty much. So the last application I'm running this time was just a basic voice stream, again in a full mesh between all the sites. And for a voice call, we also provide the MOS score, of course, which is the voice quality indicator. So you can trigger on a combination of loss, delay, jitter, packet loss, and so on in a single metric, and also keep track on how voice behaves over time.
From a security perspective, do you have what sort of granularity do you have for the accounts that people are logging in? Can you restrict what they see, what they can touch?
Yeah, we have a few basic roles, like administrators, read-only, admin, and so on. But I don't have really time to go into details, but we have some basic access control.
Thank you.
Okay, so this was the global L3 VPN. So we can also take a look on how the Wi-Fi is monitored and measured. So instead of looking at the global L3 VPN, I also have a group for office Wi-Fi monitoring. In this view, we have actually deployed one of those physical boxes just in our office using the office Wi-Fi. And on the office Wi-Fi, I'm testing the internet access as a normal user would be doing. So in this case, I'm accessing google.com, and I'm doing it once per second. And I measure the setup time, so the syn-ACK dance, and also the time to the first byte. And of course, again, here we have the full history. So if I'm curious about how was Google actually responding to my office Wi-Fi yesterday, I go to the 24-hour view, and I go back one day, and I can look at it, and I can compare it to today's values, and I see how all of these values are changing over time. So this is representing real users' experience of a service in a very accurate fashion, I think.
So with the wireless monitoring, are you only doing like responses to either Google or something, or are you also looking at like what's my RSSI values and that type of thing that the client is seeing?
Great question. So this was just looking at the actual quality, but we also can store the radio parameters in parallel. So we have something called a Wi-Fi logger. So this is the radio parameters for the same time. So what is the link bit rate? What is the different guard interval parameters? How many channels are we using? How much TX retrieve do we have, and so on. And this comes from the client side. And it works on any Wi-Fi network, of course.
Is there maximum number of monitors or tests you can configure?
Yes, everything has limitations. A single system today supports around 20,000 concurrent tests or monitoring streams, so you can get quite far with that. But also, we do provide the APIs northbound, and the system is designed to have you have one deployment covering this domain of thousands of streams, and then you could have a separate one here, and you orchestrate it over the APIs. Because what I'm showing you now, how you configure it in the GUI and so on, this is great for a demo or doing initial configuration, but in the end, you want to automate it. You want to do this over APIs because you don't want to go in here and look at KPIs continuously and tune the parameters. You want to have it fully scripted, running from the normal.
You can do a mass push of test scenarios to your clients.
So there is a few batch tools in here to do the same thing for 10 test agents or 100. So there is some tools to help you do batch management in the GUI also.
Do you have the capacity to set QS markings on the reflection type tests so that we can actually test different classes on a WAN or something like that?
Yes, very good comment. I forgot to mention that earlier, but most of the data we generate we can put into different DSCP markings, so we can put them into different expected behaviors, and we can also check that the QS is distributing traffic as it should.
Right, so we could set up multiple tests for different queues to the same destination and see performance.
That's a very important use case for us.
Excellent.
And I'll show you that in the next part of the demo, how we actually configure that.
Excellent.
Another kind of cool thing is that all of the test agents that you deploy actually also works as a speed test responder. So this is a web-based speed test where you can go using a normal web browser. And you start with selecting to where they want to measure my bandwidth. So this is a troubleshooting tool for end users or people sitting somewhere that want to check what is my connectivity to the Azure server on the US East Coast. You put in a comment and start running the test. So this is kind of similar to the public speed test, but with the large difference that we are running in a controlled environment. The test agent could be in the local VPN. It doesn't go out on the internet. You don't test the internet access. You test your backhaul performance to selected sites. So this is quite an appreciated tool among many of our customers, I think. And yeah, it seems like the Wi-Fi here is actually working pretty well. So 20 megabit per second. And it's also picking up the round trip times for TCP and ICMP. And ICMP seems to be blocked, so no success there. All of these measurements are also collected into the backend. So we take note of who was running the speed test and what was their result. So this is the backend part again. And here I'm seeing that the last speed test that was executed was running with these details. So that allows me to troubleshoot also from the backend side.
Big TCP info there.
Good idea. So yeah, where we can explain to you how the TCP stack was behaving during the test, what is how many packets in flight we had, what was the round trip time, and so on. So it's a quite good tool to understand how the network is providing TCP performance to a normal end user using a web browser.
How long are you keeping this data for to do historical checking?
Good question. I don't know that on top of my head actually, but I can look it up and we can take it tonight.
Especially with Wi-Fi, it's good to, this guy's complaining about this today or, last week. How can I compare?
Sorry, no, I thought you meant the speed test results.
I mean any of it.
But the metrics that we provide for the test and monitors, it's configurable how long you want to keep them. So you can keep them just for a short time, like the last 12 hours, or you can keep it for many days. I don't know the raw metrics for. Do you know, Mats?
No, I don't have it from the top of my head.
Yeah. It hasn't been a concern really to storing it. It's just disk storage.
And is that just a scalable thing? Like you just throw more storage at the solution and you can store more data, or is there other limits on it?
Right. So, more long-term storage requires more disk, and doing the 20,000 streams with months of data is we're talking about a terabyte, so it's quite small.
Right. And the data is stored on the central controller.
Mm-hmm.
It all gets pushed back to the controller. Yeah.
Good question. So all the test agents are stateless, kind of. So they just do the measurement, and on a 30-second basis, it just pushes it to the control center and store it there. So the test agent is disposable. So you can spin it up, do your test and monitors, and then take it away. You don't lose any data because it's all pushed up. Yeah. So it's very convenient to work.
And the controller can be on-prem as well as cloud?
Yeah. So as Matt said, we've been doing it as a software as a service for 10 years, but you can deploy the exact same software on-prem.
On-prem, okay.
Do you have an idea of overhead? So like, if you have a node running this many tests, how much bandwidth that's going to require for uploading to the cloud? Obviously, that becomes a limitation as you scale up bigger numbers.
Exactly.
The control session is only the result of the measurements. So we're talking about kilobits on average.
Okay. Per
test agent.
Test agent.
So if you have 1,000 test agents, yes, we're talking about a few megabits.
But there's no dramatic, bandwidth increase.
No, it's extremely lightweight. It uses compression and everything, so it's really efficient in providing it.
Okay.
And we don't exchange any data between test agents. When we tell two of them to run a test, they only run the test data, nothing else. And both of them individually pushes it to the control center.
That's interesting. Okay.
Okay, so to demonstrate how we start from scratch, I'm actually going to do a complete greenfield installation for you in a few minutes, so everything works out as it should. So I'm going to switch to this system. So this is how it looks when you get the product. So this is an empty control center. We have no monitors, no tests, and no test agents. This is a test agent inventory. So to help me spin up things quickly, I'm going to deploy a number of test agents in Google Cloud for convenience. But it could have been VMware or KVM or Cisco routers or something like that. So to spin up test agents, I'm going to use Cloud Init. So Cloud Init is a way to provide day zero configurations because I don't want to go out to every test agent and enter details on what is the control center is on. So I provide that with a Cloud Init file. The Cloud Init file looks something like this. Can you guys see the screen? Is that okay? Yeah. So this is the content of a Cloud Init file with the password censored for this test. Because I'm running it on the normal wide open internet hosted solution, so I don't want to share the password with you for now. But we'll set up a trial for you if you want to try it out by yourself, of course. But this is my demo environment. So this is the day zero configuration. Here I have a bash script that takes the day zero configuration and just spins up a number of machines in 7 different availability zones and regions around the world. So one-line command, pretty much just iterating the zones. And for the day zero configuration, we're also replacing the name parameter with the actual name so that they boot up with a name that makes sense to us. So let's see if it works. So I'm going to start the deployment. And I'm going to switch to the GUI to see if this is where they should appear. Yeah, there they have just started booting. So the process is that the software is now deployed in the test in each availability zone. This is a 200 megabyte compressed image that is just copied to each zone. A machine is created and it's told to boot. And the first thing it does when it gets its IP address is to contact the control center. So what I will see here, in this one. Yes. So in my test agent inventory, I can see that they are actually starting to call home. So they are popping up here. So we can see that they have just made initial contact. So that means that they are registering. So they are not fully online yet. When they are green, that means that they are all up and ready. They have the latest software version, and they are ready to be used for a test or a monitor. And this arrow just indicates that the software version is being checked, that it's running the latest one. And once it's confirmed, it will disappear. And this is also where I could push out new versions. So if I want to do an upgrade, I would just select the ones I want to do an upgrade on and say push a new firmware version to these. So it's really, really easy to manage a fleet of test agents, both in the process of spinning them up and also upgrading and maintaining them. It's also from here where we can go into a test agent and do fine-tuning of how it should behave. If I would have given it multiple network interface cards, they would have been available here, and I could go in and give it different VLAN IDs and so on. So it's all managed through the control center. You never need to go to the test agent by hand and do this. It's all centralized, which makes it really, really easy to work with from a orchestration point of view, API point of view, and also GUI point of view.
What does the bootstrapping process look like? Like, how does it check in, get to the controller?
Right. So we have a SSL connection, and it authenticates with a username and a password, and after that, it exchanges a certificate. So the password is not stored on the box, but it gets a unique private certificate that is used to set up a SSL connection.
Okay.
So it's a highly secure communication channel. And it's a single TCP session. It's NAT-friendly, firewall-friendly. You just need to be able to reach the control center on one TCP port.
Okay.
And then we run all orchestration and results over that same channel. OK, so one of the things that you typically want to do when you have deployed a new site is that you want to test that everything on this site is accessing my other resources as it should. So this is where test sequences come into play. So a test sequence is a number of tools, as Mats explained, running in sequence. And to save some time here, I have actually prepared a little template for this. So maybe I want to test my new site in Tokyo. So I create a test for this, and I'm going to use a pre-configured template. So I'm going to use the template called site-to-site activation test. And I will explain how that looks in a minute. So I'm going to say that my reference server for this will be one of my servers or test agents in the US East Coast, and the client will be the test agent I just booted up in Tokyo. I could run this immediately, or I could also make it a scheduled test, or I could make it a reoccurring test. So I can say that I want to run this sequence of tests once per day, once per week, or something like to have a baseline and a reference for things in the future. But for now, we'll just run it manually. So I'm starting the test, and this template consists of 5 different steps. Step 1 is doing a path MTU discovery, checking that the MTU is correct from end to end. Then we are doing DSCP checking of various ports, because we expect a certain behavior on port 2280, 443, and 8080 here. So the system sends traffic with a certain DSCP and check if it's receiving with the expected DSCP. And this is just a connectivity test, but it could also be a bandwidth test where we actually stress test each port and DSCP to check the QS settings. And I think this sequence will take, maybe a minute more to finish, because it does everything one step at a time, and it analyzes the results. And if everything is meeting expected KPIs, we get a green checkbox. So the test was passed. Third step is doing continuous voice calls, 5 concurrent voice calls in parallel to TCP. So we're putting some load on the link. So we're doing a 5 megabit TCP session, and in parallel, we're doing 5 voice calls. And I can see here in real time how the data is coming in between the sites. So this is my delay. I have a 75 megabit one direction delay in the voice call. I'm getting a MOS score of 4.4. And I can also follow this in real time like this. So maybe if I want to look at jitter, I can say I only want to have a graph of my jitter as the voice call comes in. And here we are seeing how those 5 voice calls are all transiting the network from Tokyo to the US East Coast. We could also look at the MOS score. We could look for packet loss and so on, but I think in this In this demo, it's going to work well because we're using the Google backbone. So I think they don't have any large issues at the moment. So that's good for my demo. Always nervous to do these live demos in the real world. You never know what happens. So that was the voice UDP, and I can also see that my TCP session was getting a stable 4.999 megabit of actual throughput. But of course, I could have told it to use a gigabit or 5 gigabits of traffic to really put a stress on it, but that would also put a stress on my bill from Google later on. So I'm just saving some money there by doing 5 megabit per second. The fourth step in the test sequence is doing an RFC throughput test. So this is a standardized way of measuring bandwidth between two locations. And it's RFC standardized, and it explains how we're going to set buffer sizes according to round trip time. So this test is going to figure out the MTU, it's going to measure the base round trip time, then it's going to set up a TCP stack that correlates exactly with the network parameters, and it's then going to stress test this session to measure what is the good put between two nodes. This is sometimes requested by operators or the customer of operators that we want to have a standardized way of assuring that we're getting the right bandwidth between sites. And this will take just a few seconds to finish, I think.
Will this expose if packets are out of order at all?
Yes, we also capture packets out of order. That's also a parameter that we look for. While this is running, because it will stress test for a minute or so, I can just show you how we configure this. So this is a template configuration. So everything is built in the GUI in a template manner. So I decide what things I want to do in what order and for how long. This is also where I put in the KPIs of what I'm looking for. So the MTU test is looking for MTU of 1400. The voice test is looking for a MOS score of 4, and so on. So everything is configured here in the GUI of how you build a template. But then you refer to it using the APIs. And this is also convenient to use. If maybe I want to change the orders, I want to do the voice call and bandwidth test first, I just put it first. And maybe I want to also combine it with another concurrent or parallel task. So I just add something to the flow here. So I could say I also want to do a multi-session TCP, setting up 100 TCP sessions to really stress test a firewall, for example. Going back to see if my test was finished. No, it's still running. I made this test sequence a bit too long. Now the last 5 steps is checking internet access. So checking the response type of a few websites, doing DNS lookups, and pinging a few internet hosts.
I do have a question for you while that's running then. Mm-hmm. So your hardware device, what exactly is that? Is it a Pi? Is it a NUC? What are you?
x86 64-bit CPU, small Intel, industry PC, not very fancy hardware at all. It's just small and convenient to use.
So out of curiosity, these are all individual tests. What are you doing around correlation across for site-wide component failures? Things like DNS just stops working, right? So obviously that's going to test within the step 5 component, but you're the impact site-wide or maybe globally. So
we do some basic aggregation. So basically a monitoring group will be an aggregation of all streams in that group in one view. So if a few of them fail at the same time, we just give you one failure, say that this group failed at this time. And we can say that it included these different streams all being affected.
Okay. So you are doing some inference related?
We're doing basic correlation between streams on a time basis. So if it happens at the same second, we think it's the same fault affecting both, if it's from the same test agent or same monitoring group.
If you have multiple circuits to, to different data centers or whatnot, how would you monitor circuit health on if you run an ECMP or something to that effect?
No, we use the network as an end user does.
Okay.
So we don't care about if it's load balanced, if it's using multiple links. In that case, we can deploy multiple test agents emulating a full load on that link as users would be using it. So we take the approach of always using the network as a user does.
So if one circuit is having an issue, this package here would help me at least identify if there's a problem, but then you'd have to at least jump in and figure out which circuit is.
Yeah, exactly.
Okay.
But we find that there is an issue. That is the value.
Gotcha.
Okay, so the test is finished, and just as a last step, we also attach this with a PDF report telling you that this is a site activation test, was executed by this user at this time, this is the results per step, and then pages after pages of metrics and details and graphs and data that you can basically print on paper and leave on the customer's desk, saying we have tested our delivery of the service to you guys. So if anyone is curious about the RTT under load from the speed test, we have it in the report. Okay, so
The API, perhaps.
yeah, so that's a good suggestion. So just to give you some feeling for the API, we provide a Swagger API, a netconf REST API, and everything I showed you during the demo, you could easily do with simple REST calls. So you have everything well documented, super easy to use. And this is how we recommend to use it on scale. So if you have 5 test agents, use the GUI. If you have 500, use the API.
And that documentation is publicly available.
Yeah.
Like, you don't have to be a customer, you can get at it.
We are very open with the documentation.
Right.
Our whole product documentation is available for anyone, so it's and we're happy to give out trial accounts also for you guys to test it out.
The API, obviously, you mentioned your partnership with Cisco earlier on. You have other partnerships that have been built around with people that use the data from your tool. Is there anything else that's already built?
I think for time reasons, maybe we can save that question for tonight.
Okay.
Because I just have a few minutes left.
Oh, that's fine.
And I want
Absolutely.
to just take one more. Because it is a long discussion, and yeah, it depends on who are of interest. So I'm going to switch to just the last demo, which is around service chaining. And this is how we can use the network, the test agent in a smart way to monitor service chains. So in this scenario, we have a branch office, and we have a SD-WAN, and we have a public cloud on the left. We have deployed a service chain consisting of 3 VNFs. We have a router, IPS, and a firewall, and they run in the same hypervisor domain. What we can do here is we can deploy a test agent with multiple network interface cards sitting in different steps on the chain. In this example, we have put one leg on the inside, one on the outside. And since they are different routing domains, we can actually send traffic in loops like this. And this is really cool because the timestamps and the accuracy is microsecond level at this point in time, because we have the same clock on the sender and the receiver. So we can tell you on microsecond level what is the jitter in your service chain. So this is kind of a different thing comparing to collecting syslogs or SNMP traps, because here you get the actual performance for different protocols and different usage patterns. Additionally, to pinpoint where in the chain a problem occurs, we can give it more network interface cards. We can put it between VNFs, and we can run traffic through the whole chain, but we can also do it per VNF at a time. And this is just normal routing happening. So no magic really, besides that we have multiple NICs with namespaces and very accurately time-stamped packets going out and in. So we know exactly what happens at each step.
So this isn't aware of any of like the service chain is going on. You're just sending the traffic as a synthetic test.
Exactly. This is how you would apply it into the environment and say, use it in this way and look for these KPIs and behaviors.
It'd be really great for like convergence testing. Like inside of a data center, like, my routing protocol fails, I lose a link or a primary path. Like, what does that look like, and what does that actually mean for me? Optimizing those things is really cool.
Yeah. And just to give you a last look on how this looks in the system, I'm going to find my demo environment. By the way, this is a multi-tenant system, so I'm just switching between different tenant accounts on the same control center. So I'm back to the old demo, which have been running for a while, and there I have a service chaining monitoring group for running inside VMware ESX, but of course it doesn't really care about the hypervisor environment. It just happened to be a VMware hosted service chain. So here we are again seeing the last 15 minutes of the service chain. We have the VNF 1, 2, 3 in series. And here we can see that traffic going out on one interface and in another one is having a packet loss of 0.39% and a delay of 4 milliseconds. So this is for the past 15 minutes. Imagine if you had 5-minute averages, then this is the value you would have for that 5 or 15-minute average. But we store it with very high granularity, so you can, of course, drill into what happens on a 10-second resolution in this case. And here we see that, yeah, the average was 5 milliseconds, but actually it's 50 milliseconds for a few seconds, and then it's back to almost 0 again. So clearly the service chain has some kind of problem. I can also show the packet loss, and packet loss also happens at the same time as we have average delay increases. And just basically correlating this, I can see that it happens occasionally. And if I just look at the green bars, I can see that the individual chains here, or the individual VNFs, the firewall and IPS and the router and firewall is all green, everything is fine there, but the problems correlate exactly with traffic only traversing the IPS. So super easy, clear root cause identification of that this is the weak chain. And I can do the same thing here. I can drill into it and look at latency over time. And yes, looks exactly like the full end-to-end chain. And just for reference, if I would look at traffic going through the firewall, we would be seeing a super stable pattern. So in this case, we have a 0.1 millisecond latency through the firewall. And if I look at jitter, I think I have quite a low value here also. Yeah, so no jitter. So clearly the IPS was the bad VNF here.
Do you have a view that kind of shows that whole path of I touch this hop and?
You can do hop-by-hop tracing also. So I have that set up here where I'm just doing per hop monitoring, but it's not a good way to troubleshoot this because it's CPU dependent rather than following.
If you have an agent within the network and I'm testing all the way out to Google Cloud, how do I figure out where the problem is using this?
Right. So of course, doing a trace route gives you an indication of it. But if you're running inside a VPN, it's very little that we can do from our perspective to tell you that the actual problem is this link. You basically need to be in that network to do that. So that's not something we cover really.
Yep.
Okay. So I think we are running out of time here. So I think I will just hand over to Mats for.
Yeah, I think also what Jonas did an excellent demo, and you actually set up a complete test infrastructure in less than 1 minute. I'm not sure if everyone really realized the power of this. You set up in seven countries in all the continents of the world, setting up a private test infrastructure basically. So there is no need to leverage other third-party providers. You can set up your own. You can fully control it, and you can even blast up to 100 gig if that would be relevant in some of your scenarios. So we would be more than happy to discuss and continue the conversation over dinner tonight. And feel free also to reach out and anyone on the live stream to nfd20@netrounds.com with your questions, feedback, and even requests for your own. You can either have a SaaS account that as Jonas used now, or you can have an evaluation license for our on-prem software. So thank you so much, guys.
Thank you.
Thank you.
Thank you.
Thank you very much.